Hey guys, we are back again with a new video that talks about the SAT subject test in physics. In today's video, we're going to solve some real classified questions on lesson 2. This is Khaled Mustafa and I'm going to be with you in this video. Lesson 2 is kinematic equations. What are kinematic equations? And before we can start, let's please have a quick look on the 3 equations you have to keep to be able to solve all the questions. The first equation is V final, or the final velocity, equals V initial plus AT. The second one is X, which is displacement or distance, equals VI, V initial times time plus half times AT squared. The third equation is V final squared equal V initial squared plus 2AX. We have V final as final velocity and V initial as initial velocity. A is the acceleration, T is the time, and X is the distance or displacement. If you look closely to these equations, you'll see that each equation has 4 quantities, 4 physical quantities. You'll be given 3 of them, and it's required to find the fourth one. Let's save time and start with question number 1. An object starts from rest and accelerates at 4 meters per second squared. How far will it travel during the first 3 seconds? Okay, your first step in every question is to find every single given quantity. We have an object starts from rest. Okay, starts from rest. This means we have an initial velocity of 0 and accelerates at 4 meters per second squared. Accelerates at 4 meters per second squared. So we have a positive acceleration, which is 4 meters per second squared. How far will it travel? So we need to find the displacement or distance during the first during the first 3 seconds. So we have t equal 3 seconds. Now you have 3 given variables so that you can easily solve the equation. Okay, which equation will we use? Can you figure it out? We need to find the displacement or distance. Fine, we have 2 equations that have displacement or distance, but we don't have the final velocity. So we are going to use the second equation. So the second equation is X equals V initial time plus half AT squared. We have an initial velocity of 0, so this term is cancelled. Half times 4 times 3 squared. Half times 4 is 2. 2 times 3 squared, which is 9. So we have 18 meters. So the answer is B. Question number 2. An object near the surface of Earth falls from rest. Again, what does it mean for an object to fall from rest? Falls from rest means we have an initial velocity equals 0 meters per second without air resistance. After 1.5 seconds, so we have time of 1.5 seconds. After 1.5 seconds, it has not yet hit the ground. The speed of the object at this time is most nearly, so we would like to find the final velocity after 1.5 seconds. Okay, now you have just 2 given physical quantities. There is one missing. Can you figure it out? Yes, any falling objects fall under the gravitational acceleration, which is 10 meters per second squared. You have to keep it. So we have now 3 given quantities, 1, 2, and 3. So now we could easily find the final velocity. Which equation we are going to use? Have a quick look on them. The first one, yes, we have to use the first equation. So V final equals V initial plus A t. We have initial speed of 0. We have acceleration due to gravity is 10. So 10 times 1.5 is 15 meters per second is the final velocity. The answer is C. Let's move to question number 3. A person drops a stone from the top of a well. Drops a stone. A person drops stone. Take care. Now we have a gravitational acceleration. Every falling object falls under the gravitational acceleration. So your first step is you have acceleration due to gravity, which is 10 meters per second squared. A person drops a stone from the top of a well and it hits the water 3 seconds later. T equals 3 seconds. The distance from the top of the well to the water level is most nearly. We would like to find x. Now we have 1, 2. We need the third variable to be able to solve this equation. The word drops means you have an initial speed of 0 meters per second. Don't forget, it's very important. So we have now initial velocity of 0 meters per second. We need to find the displacement x. Yes, it's a second equation. So we have x equals v initial t plus half a t squared. The initial velocity is 0 and this term's cancelled out. We have half times acceleration, which is 10, and time, which is 3 squared. Half times 10 is 5. 3 squared is 9. 5 times 9 is 45 meters. The answer is C. Question number 4. An object falls freely from rest near the surface of the Earth. It has fallen for a time t, but it has not yet hit the ground. The acceleration due to gravity is g. If the air resistance is negligible, the speed of the object is most nearly. So now we have a falling object under acceleration. So the acceleration due to gravity is g, and it falls for a time t. An object falls freely from rest, which means we have initial velocity of 0. And now we would like to find the final velocity of the object. So if we use the first equation, which is v final equals v initial plus a t, the initial velocity is 0, so we have acceleration times time. The acceleration is now g due to gravity multiplied by time, so the final velocity is gt. The answer is C. Very good. Let's now move to question number 5. Ball 1 is thrown straight down from the top of a building with a given initial speed. Top of a building. This is ball number 1, and it's now being thrown down given an initial speed. Let's call this V initial. We have, at the same time, ball 2 is thrown straight up from the top of the same building with the same initial speed. Let me draw this here for ball number 2. Ball number 2 at the same height from the same building is thrown straight up with an initial velocity Vi as ball 1. The air resistance is negligible if ball 1 has a speed v just before hitting the ground. So ball number 1, as it leaves the edge, as it's being directly thrown downwards from the top of the same building, Very good. Let's now move to question number 5. Ball 1 is thrown straight down from the top of a building with a given initial speed. So we have a building and we have ball number 1 is thrown straight down with an initial speed. Let's call it V initial. At the same time, ball 2 is thrown straight up. Ball 2 is thrown straight up at the same height and at the same time with the same initial speed, which is Vi. The air resistance is negligible. If ball 1 has speed V just before hitting the ground, so ball number 1 just before hitting the ground, at this point it has speed of V. What is the speed of ball 2 just before hitting the ground? What about this final speed of ball 2? Okay, take care, this is a little bit tricky. We have ball 1 started to gain velocity as it moves downwards. It's gaining velocity, it's moving with gravitational acceleration. So ball number 1 at this point has a more value for velocity than the initial velocity. What about ball number 2? Ball 2 is being thrown straight up, so it moves until it reaches the maximum height where V equals 0 and then it comes back again. Okay, can you figure out what is the speed or velocity of ball 2 at this point? At this point. Yes, we have said this in the last video. Ball 2 moves straight upward from this point to the maximum height. As it's moving upward, it has a decreasing velocity until it reaches the maximum height where velocity equals 0, and then it came back moving downwards with gravity. So it has an increasing velocity until it reaches this point at the same height, and its velocity is going to be V initial again, the same as the point where it was projected upwards. So at this point, ball number 2 has again a velocity of Vi. So ball number 2 and ball number 1 at the same height, under the same conditions, they both started with initial velocity of Vi. Ball number 1 reached a final velocity of V, which means ball number 2 will also reach a final velocity of V. So C is the correct answer. Okay, question number 6. An object is moving in a straight line with an instantaneous speed of 8 meters per second when it begins to slow down with a constant acceleration of 2 meters per second squared. How long will it take for the instantaneous speed to reach 2 meters per second? So we have an initial speed of 8 meters per second, and it begins to slow down. So we have a negative acceleration. So the acceleration is negative 2 meters per second squared because it's slowing down. How long will it take? So we would like to find the value of t for its instantaneous speed to reach 2 meters per second, to reach a final speed of 2 meters per second. Now we have 3 given quantities. We can easily solve this equation. The first equation, V final equals V initial plus A t. Would like to find the value of t. So V final is 2, V initial 8, the acceleration is -2, so we have -2 multiplied by t. So we need to solve for t in this equation, so it's -6 equals -2t, which gives t equals 3 seconds. So the answer is C. Okay, that's all for today, and wait for the next video for this same lesson, kinematic equations. There will be another part of this video. Thank you so much and good luck.